So this question is saying a microscope is focused on an object at the bottom bucket. A liquid of refractive index 5/3 is poured inside the bucket. Then the microscope has to be raised by 30 centimeters to focus the object again. So what is the height of the liquid that was poured in the bucket? Okay. So basically, the term, this word microscope is written in the question just to confuse you. Okay. There is no use of that microscope formula or anything like that. Okay. So yes. So what is happening here? There is a bucket. There is a bucket kept here. Okay. And one object was here at the bottom. Okay. And this object was being observed by a microscope. Let's say the microscope was here like this. Okay. So it was being observed by the microscope, right? So a ray of light, if it was emerging from the object, it was going straight away like this to the microscope, right? So whatever is this height, this height, whatever it is, it has to be maintained. It has to be maintained, whatever it is, it has to be maintained so as to focus on the object through the microscope. Okay, this has to be maintained. But what will happen when you pour some liquid is poured? So when you pour some liquid in this one, what will happen? Now if a ray emerges, from the object here, so it will be bending away from the normal. The ray of light is going from a denser medium to a rarer medium, right? So now it will appear that the object is here at this point, right? It will appear to the microscope that the object, the ray of light, is as if it is coming from this point. Okay, this point here. So this is the apparent position of the object now, right? So now see, this is the change that has occurred due to the pouring of that liquid. Okay, now the microscope is feeling or is observing as if the light is coming, as if the object is here. Okay, so apparently the object is lifted by this height. Okay, so I'll make a clear diagram for this one to explain this, how to take, what to take. So just let me make another diagram. So this was just to make you understand. So let's say this be the position, this is the tub, the bucket, and the object is kept here. This is the real object kept here. Okay, initially, and there is some liquid poured in the bucket. There is some liquid poured in the bucket right now, and the refractive index of the liquid is 5/3. Okay, now if a ray of light emerges from the object here, it will be bending away from the normal. We know it will be bending away from the normal. Okay, so now this is the apparent position of the object, O dash, let's say O prime, right? So that means apparently the object is lifted up by this much amount, right? So that's why, to maintain the previous position, the previous condition when there was no liquid, we have to maintain the distance between the object and the microscope, right? So now that the object seems to be lifted up by some amount, the microscope also had to be lifted by the same amount so as to maintain the status quo that was before, right? So here the question is saying that the microscope has to be lifted by 30 centimeters. That means this is 30. That means there has been a shift upwards. Okay, the distance between O and O dash is 30 centimeters, right? So the difference between the object and its apparent position is 30 centimeters. So now we can use the formula straight away that we have for apparent depth and the actual depth, right? So this will be, so we know here that this is the apparent depth, H apparent, okay, and the actual depth is this much, H real, okay. H apparent upon H real, H apparent upon H real is equal to what? Now you see HA upon HR is going to be less than 1, of course. Okay. So this is 3 upon 5. Okay. HA upon HR is going to be 3 upon 5. Okay. And this is the real one. Okay. So that means you invert it. You'll get, that means H real upon H apparent is 5 upon 3. Isn't it? I can write H real is actually the actual depth, that is going to be more, right? H apparent is lesser. So HR upon HA is 5 upon 3. Okay. And we know that the shift upwards is 30 centimeters. That means HR minus HA is 30 centimeters, isn't it? So now what we'll do, just subtract 1 from each side here. Subtract 1 from each side. Okay. HR minus HA upon HA is equal to 5 minus 3 upon 3. And now HR minus HA, H real minus H apparent is 30, right? This much is 30. Actual minus apparent is 30. So I can say 30 centimeters upon the apparent depth is equal to 2 upon 3. So from here you will get the apparent depth HA, that is 15 into 3, 45 centimeters. That means this is 45 centimeters. Now let's see what is the question asking. So the height of the liquid in the bucket is, so basically it is trying to ask the HR, the real depth, HR, right? So straight away we can say from here, H real is what? We had HR upon HA equal to 5 by 3. We had this HR upon HA is equal to 5 by 3. H real upon H apparent is 5 upon 3. So from there, if I have to find H real, that is H apparent times 5 by 3. That is 45 into 5 upon 3. This is 75 centimeters. That means the real depth, okay, this much is 75 centimeters. This thing here, option number 1 becomes the correct answer. Okay. Thank you.